Hello, today we'll go through how to draw ray diagrams for concave and convex lenses. So for each of the diagrams, we need to find and draw the image, describe the image using 3 words, and also calculate the magnification. We're also going to need a pencil and a ruler. Let's get started. First thing to note is we have a concave lens, and we can see that because we've got a cave that we walk into in the shape that's been drawn in the middle. Now it's also worthwhile just extending the size of the lens so that it's a little bit clearer when we draw it. So using my ruler, just make the lens a little bit taller. What I also recommend doing is turning our tree into a arrow, perhaps so we're more used to that. It doesn't need to be a tree, let's make it as simple as possible. So the first thing is to draw a line straight through the middle of the lens across the principal axis from the tip. So that's something like so. And also we draw one straight across horizontally, like so. Now, when you've got a concave lens, you have to use the focal point backwards. So what we now do is something like that. And then we would extrapolate backwards using a dotted line going through that focal point. And it's where these 2 lines intersect, and that's where our image is. So we could have labelled our object earlier as well. So if we want to describe the image using 3 words, well, it's the right way up. It's been magnified, as in it's got smaller though, and it's also a virtual image because they're on the same side of the lens. So to calculate the magnification, first of all, we need to measure the size of the object. Now it's difficult because I'm on a computer and you'll be looking at it on a computer at a different scale. Well, let's say for argument's sake that's 2 centimeters and this is 1 centimeter. To find the magnification, what we need to do is do the image divided by the object. So the image is 1 centimeter in my case, and the object is 2, so we've got a magnification of 0.5. So that's why it's made smaller. A number less than 1 means it's made smaller. A number bigger than 1 means it's got that times bigger. On to the next one. So again, we have a concave lens. So what we'll do is exactly the same as what we did before, is we will draw one straight through the middle, like so. And we will draw one horizontal. And now we're going to draw a line in line with our focal point this way, and then draw a dotted line backwards towards our focal point, and again where the lines intersect, that gives us our image. So we can use the same words as we used before to describe this one. So this is the right way up. It's virtual because on the same side of the lens, and it's definitely been made smaller. So if we wanted to find the magnification, let's, for argument's sake, say that this one's 3 centimeters, this one's 1 centimeter, so that will be 1 over 3, so it'll have a magnification of about 0.3. But again, you'll have to measure the size using a ruler, depending on what you've got, so you might get a different answer. Let's move on to the next one. So we've got our flag, and this one might be easier to do as an arrow to get started. And as ever, from the top of the arrow through the middle of our lens. It's still the same sort of lens as before, so we can do a horizontal one as normal, but then we need to go backwards through our focal point, like so, and then we can draw on our image. And again, same answers as before. It's virtual, it's the right way up, and it's been made smaller. So again, we can put some numbers on this. Let's just again make this up. So this is 4 centimeters. This is now 1 centimeter. So 1 divided by 4 gives you a magnification of 0.25. I should also say, just remember, we should be having arrows on these as well. and that should be the same for the other lines too, so they should be leaving the object. For the last two, we've got a convex lens, so need to remember that they're slightly different in how we approach them. So let's draw on our arrow just there for our lamp, and as ever what we do is draw one straight through the middle, and we then need to draw one horizontal up to the lens, and then that passes through the focal point. And then you might find, like me, that you haven't quite drawn the lines long enough. So it's just a case of drawing them to complete, but ideally they're one complete line. And then we can draw on where the image is, and we can see that it appears where the lines intersect. So again, we should be having arrows on our lines. So if we wanted to find the size of the image or the magnification, this one, let's say, is 3 centimeters, and it's slightly smaller, not much in it, but let's say this is 2.5 centimeters, so the magnification would be 2.5 over 3, and that gives us a magnification of 0.83. So hopefully you can see that the arrow is pointing down just here and pointing up, so we would say that this has become inverted, so it's upside down. We would also say that we've got a magnification of 0.83, so it's slightly smaller. And the other thing to say is that it is a real image, and that's because it can be projected. They're on the opposite sides of our lens. So let's look at the last one. So we've got an A this time, a letter, but again, we can just simplify it by turning it into an arrow. So first line we can draw goes straight through the middle of our lens, something like that. And we also then need to draw a horizontal one up to our lens, and after that it goes through the focal point on the left hand side because of that it's a convex lens. Now we should be able to see at this point that these lines just here are getting further away, they're diverging. So the trick with this, when we've got diverging lenses, is to then go backwards. So we can go backwards along the same line like so, and do the same for the lower line. Keep going backwards using a ruler, and at some point, if they're getting further apart on this side, they must get closer together on the other side. And then we can draw our image just where they cross, and we can see that it's the same side of the lens, so that means it is a virtual image, one that cannot be projected. It's also got bigger, so it's been magnified, and again we can calculate the magnification. Let's say this is 1 centimeter to start with, and now let's say this is 4 centimeters, so that's 4 divided by 1, so that gives us an answer of 4, so it's got a magnification of 4, and it's also the same way up. That brings us to the end of the video. As ever, if you have any questions, please get back to me, and don't forget to subscribe to my channel. Have a good day.